Okay, so in this video here, we're going to be talking about the graphs of a sine bx and a cosine bx. So notice here when I write what we're talking about here, the new thing is right here. It's at letter B, all right? So the first thing we're going to go over is what we call the period of a function. All right? So whenever we graphed y equals sine x, all right, we came up with a graph that looked like this, where it was at sinusoidal curve between -1 and +1. So there's -1, there's +1. And notice here, it goes up, it goes down, it goes up, it goes down. But the big part about this is it repeats itself. All right. So, in fact, it repeats itself from right here to right there. This distance that the curve travels is called the period of the function. All right. So sine will end up repeating itself every, what we say, every 2 pi units or every 2 pi periods. So strictly speaking, the first period, this would be y equals sine x. Then in blue from, let me do that real fast. So from in blue from here all the way over to here, this is y equals sine of x plus 2 pi because we added on another repeating of the period. All right. So in general, here's what we have. I'll highlight it in red. Right here is one complete period. So for sine, it starts at 0 and it goes all the way down to 2 pi. All right. This is, like I said, this is considered one period. Now, if we do a little investigating here and we go back to Desmos, notice here I have y equals x, or y equals sine x. Watch what happens when I do y equals sine of 2x. So notice I go up, I come down, I come up. It seems as if my period shrunk. All right. Let me try this again. Let me fix our graph here. So this looks really nice. So we're going to go from -1 to +1 in the y direction. And then 0 to 2 pi in the x direction, okay? So this is y equals 2 sine x. And when I click on y equals sine x, notice I only get one period. However, in y equals 2 sine x, in the same distance covered from 0 to 2 pi, I get two replications. All right? So what we can say is, going back here, is when comparing y equals sine of x with y equals sine of 2x, the effect of b equals 2, because remember, in general, this is what we're looking at. All right, so there's that. That's what I mean by b equals 2. So the effect of b equals 2 in y equals sine of 2x is half the period of the curve y equals sine of x. All right? So we can conclude that the period of a function the period of the function is p, and the period of the function of b of x. So if you just put a number in front of that letter x other than the number 1, it is now divided by b. So the period is divided by b. All right? Therefore, both y equals sine of x and y equals cosine of x have periods of 2 pi. That's how long it takes it to complete one oscillation. And in general, the periods of y equals sine bx and y equals cosine of bx have periods of 2 pi over b. And that is the most important part about this lesson. So, for example, the period of y equals sine of 4x, well, that's going to be 2 pi divided by 4, which is pi over 2, which means this y equals sine of 4x, we know it looks like this for one oscillation. It's going to happen from 0 to pi over 2. Normally, y equals sine of x goes from 0 to 2 pi. So notice this number out in front actually shrinks the time or the amount of time it takes to oscillate. So let's just verify that once again on Desmos. So let's get rid of this. So notice from 0, so if we start at 0, here's one complete oscillation. It comes up, comes down, comes back up, and guess what that is? Pi over 2, because that's how fast it takes. So the larger the number that b is, the faster this is going to complete one period. All right? And on the flip side, well, what if you shrink the number? In other words, instead of 4, how about 1/4? Yeah, let me just type it over again. So how about the sine, this is not working with me, of x over 4. Notice how it stretched it now. So one period goes from 0 all the way to 8 pi. Let's verify that algebraically. So, black marker. So the period of y equals sine of x over 4. All right? Well, remember, the period is 2 pi divided by b. In this case, b is equal to 1/4. So I'm going to erase the letter b divided by 1/4. Well, that's nothing more than just taking 2 pi over 1 and multiplying it by the reciprocal. 2 pi times 4 is 8 pi. Now we can apply the same exact situation to something like the period of y equals cosine of 6x. All right? Well, just remember, in general, y equals cosine of x goes from 0 to 2 pi. We also know that the period is equal to 2 pi over b. Let me write that a little nicer. So the period is equal to 2 pi over b. So in this case, I'm going to take 2 pi divided by 6, which is pi over 3, which means I'm expecting that shape to go from 0 to pi over 3. Normally, it would go from 0 to 2 pi. So let's go ahead. Let's get Desmos out and let's compare them. First, we'll do the standard y equals cosine x. All right. Oh, that looks nice right there. So notice from 0 to 2 pi, that's one complete period. Now, y equals the cosine of 6x. Remember, we're expecting the same exact shape from 0 to 2 pi, but we're expecting to go from 0 to, what did we calculate again? Pi over 3. So it was 6x. All right, now let me turn this off. And from 0, we come down, we come up, and there it is right there, pi over 3. All right. So now what we can do is we can use this to our advantage to start to quickly sketch any type of graph that we have. So in other words, what I'm really trying to say here is black marker. We can sketch, let's say, y equals 3 sine of 2x. All right. So here we know the amplitude is 3. All right, so the amplitude is 3. So right now, if I'm going to sketch this, 1, 2, 3, 1, 2, 3, I know I'm going to have my maximums and my minimums at positive 3 and negative 3 respectively. Okay? I also know that my period is going to be 2 pi. Oh, let me write period here. I also know my period is going to be 2 pi divided by 2, or just pi. So the only thing I really got to be worried about is when I sketch this, come up, come down, come back up, it's going to stop at pi. And there's my very rough sketch. Now, if I wanted to, I can figure out what those points actually are, where I have a maximum and a minimum for my amplitudes. To do this, we need to think about what's happening normally, all right? So, what I mean by that is this. We're going to go back to Desmos. Here's y equals sine x, all right? So, you can see here that we have maximums at pi over 2 comma 1, and then a minimum at 3 pi over 2 comma negative 1. So I'm going to write them down, all right? So in red, normally, y equals sine x, max at pi over 2 min at, was it 3 pi over 2? Yep, 3 pi over 2, just making sure. All right, but you have to remember, these are valid when your period is equal to 2 pi. Our period is now equal to pi. All right, it shrunk a little bit. So what we're going to have to do for our max is we will adjust by that. So our new max is just going to be pi over 2 divided by b. And in this case, b is equal to 2. So pi over 2 divided by 2, which is the same exact thing as pi over 2 times the reciprocal. So it's now shifted to the left to pi over 4. All right, so that's how we get pi over 4 comma 3 for our max. Same thing applies for the new minimum. So in blue, off to the left, so I can keep everything on one page. So our new minimum, all right, is going to be the original 3 pi over 2 divided by b. So it's going to be 3 pi over 2 divided by 2, which is 3 pi over 2 times 1/2, or 3 pi over 4. So that's our new minimum. To be 100% honest with you, the easiest thing to do is to just go right into Desmos, just to verify. So let's turn off this graph. Let's type in hours. Y equals 3 sine of 2x. All right, let me fix this a little bit here. And let's just make sure. So I'm going to click the max. We get pi over 4 comma 3. Nailed it. Our new min, 3 pi over 4 comma negative 3. Nailed that as well. So the moral of the story here is you always want to start with what you know, which is in purple. It's the normal one. And because the letter B, which is in front of the x value, shifts our graph left and right, it's going to shrink it. Well, actually, we call it compress, all right, or stretch. That is going to affect all of your x values as well. So whatever B happens to be, you're going to take every single point and divide by it. So I hope this helps, and I will see you in the next video.